linear. Here, that's the first one. Then we had, just a second. So then we had a trigonal planar shape, which is that if you had three bonds, then 3 bonds would be as far away from each other as possible, and it's going to be fan shaped, which is called trigonal planar. Then you have 4 bonds. In 4 bonds, अच्छा एक second देना मैं, let me just type a message. Just wait 1 second, sorry. Sorry. So if you have 4 bonds, it's going to be tetrahedral, and then you had 5 bonds, which was trigonal bipyramidal. There's going to be a fan, 1 bond on top, and 1 bond sitting at the bottom. And then you had 6 bonds. 6 bonds would be that all of them would be as far away from each other as possible, and it's going to be called octahedral, 90 degrees top, right, left, bottom, 1 behind it, 1 in front of it. So this was how 6 bonds would be arranged. And then we had different derivative shapes, which were that sometimes what would happen is that you would have, instead of 3 bond pairs, they're going to be 2 bonds, and on one side there would be lone pairs, outer shell electrons that are not involved in bonding. So since you do have those electrons over there, so the repulsion would be exactly the same. The arrangement would still be kind of fan shaped, except that there's nothing attached on the top. So it's like a fan with the top missing. So the angle would be approximately the same, except that the lone pairs are closer to the atom, so which is why they cause greater repulsion. Bonded electrons, they get stretched upwards towards the other atom. So the lone pairs, they always cause more repulsion, so which is why the angle kind of decreases by 1 or 2 degrees. And the shape is going to be bent. It's like a fan with the top missing. The tetrahedral shape would also have a few different derivative shapes. For example, instead of 4 bonds, you have 3 bonds, and on the 4th side, there's a lone pair. So it's like a tetrahedral shape with the top missing. If the top is missing, it looks like a pyramid now. So it's going to be trigonal pyramidal, and the angle shrinks a little bit because the lone pair causes more repulsion. Then you had this 2 lone pairs, so the angle shrinks further. So I'm just going to practice a few questions so you can figure out the shape of a molecule. For example, let's do a few examples first so that we can figure out the shapes of molecules. So I've got an HCN molecule. So I've got an HCN molecule. So it's got a triple bond. So here's my HCN molecule. Now, so here's my HCN molecule. Now the HCN molecule, the only thing that you have to be careful about when you're talking about shapes of molecules is that you have to be very careful about lone pairs. And it's always, the shape is always determined by the central atom, the one that's in the middle, that's sitting in the middle. We don't care about the atoms that are at the ends. It's always the arrangement around the central atom, the one in the middle. So carbon is in group 4. So it has 4 electrons. So 3 electrons shared over here on the right side, 1 electron shared over here. So there are no lone pairs. There's nothing left. So it's just 3 bonds and 1 bond over here. So the shape is going to be linear. It's going to be 180 degrees. So you've got 2 pairs of bonds, a triple bond on one side and a single bond on the other side. This one is going to be 180 degrees. We can try and figure out the shape of an SO2 molecule. And the information that's given is that S and O form double bonds. So we know that if you have an SO2 molecule, the S is going to form double bonds with oxygens. So the question is, I mean, this is the structural formula. I haven't drawn the actual shape. So the question is, what would be the shape of this particular molecule? Now you've got sulfur over here. Sulfur is in group 6, which means that it has 6 valence electrons. So it shared 2 of them over here, 2 on the other side. So you're left with 2 electrons. So that means you've got how many pairs? You've got two bond pairs, one pair of bonds over here, a pair of bonds over here, and you've got a lone pair on one side. So the shape of a molecule would be that when you have two pairs of bonds and you've got one lone pair on the other side, the molecule shape would look like this. So I'm going to draw this molecule in the exact same arrangement. So it's going to be sulfur, and they're going to be oxygens, and another oxygen, and there's going to be a lone pair that's sitting on the top. So this is how an SO2 molecule would actually look like. So that was example number 1. This is example number 2. And after this, we'll do some past paper questions related to shapes as well. Let's do another more complicated molecule. For example, you're given a molecule of so this here is my molecule. Now they're asking, in this particular molecule, they're asking about the angle or the shape around this carbon atom. Now around this carbon atom, you've got how many pairs of bonds? Remember, think of the double bond as one thing. So there's one pair of bonds over here, one over here, one over here. So there are 3 of them. So when you have 3, that's going to be fan-shaped. So that means that the first carbon atom would be fan-shaped. All the angles would be 120 degrees. It's going to be trigonal. It's going to be trigonal planar. Okay, so this is how the first carbon atom would look like. And it would then be attached to the next carbon atom, which would also be fan-shaped because there are 3 pairs of bonds. So all 3 would be as far away from each other, just like a fan. So this other one would be fan-shaped as well. So around this carbon atom, things would be like this. It would be 120 degrees. Then you move to the next carbon atom, and that would be fan-shaped as well. 3 pairs of bonds, one over here, one over here. They'll be as far away from each other as possible. So this one would be C double bond O and one bond on this side. So I move to this carbon atom. And then the last one, it's 3 pairs of bonds. One thing you have to watch out for is the lone pair. N is in group 5. That means it's got 3 bonds. So 3 electrons busy with bonds. There are 2 electrons that are left for N. So it's basically 1 lone pair and 3 bonds. So 1 lone pair and 3 bonds is this shape. 1 lone pair with 3 bonds. So it's a pyramidal shape. So this particular N over here is going to have a pyramidal. So it's going to have a pyramidal shape with the lone pair that's sitting on the top. And this would be an H, and this would also be an H. So the angles are, all the other carbon atoms were 120 degrees. All of them were fan-shaped or approximately 120 degrees. Whereas this one is going to be 100. It's going to be 107 degrees. This one over here would be 107 degrees because 1 lone pair with 3 bonds is going to be exactly that. Okay, so we're going to do some more past paper questions. Abhi, clear? Is this clear so far? Yes or no? Is this clear? Asad, Amna, Freen, Aisha, is this clear? Raid? Yes or no? Sidra, is this clear? Clear है कि नहीं clear? So just type in chat के लिए type कर दिया करो. So we're going to do past paper questions related to. Somebody asked for the market scheme or something. I'll send it right after class. As a specific shapes, we're just going to focus on the shapes of molecules. Just a second. So bond angles and molecular geometry, etc. And we're only going to do the questions related to shapes. So we can figure out the shape of a molecule. Now this question over here. Let's try and do this question. It says that ethane burns in oxygen to produce carbon dioxide and water vapors. So ethane is this thing. It's carbon. If you've forgotten organic chemistry, you can just Google ethane and you'll figure what this is. Otherwise, you should be, even without organic chemistry, you should know that this is ethane. I've got a carbon dioxide molecule and I've got a water molecule. So I've got a water molecule as well. Now he's asking for the angles in ethane. So first one, ethane. Focus on the central carbon atom. Ignore all the rest. The central carbon atom. I mean, both of them are central carbon atoms. So the carbon is making 4 bonds. So when it's making 4 bonds, anything that makes 4 bonds has this specific shape. It's tetrahedral. The angles are all 109.5 degrees. So this carbon would be tetrahedral. The other one would also be tetrahedral. So in reality, ethane is going to look something like this. Like if I draw ethane, it's going to be one tetrahedral carbon atom. So C with 3 H's. And attached to the other carbon atom, which is also going to be tetrahedral. So it's going to be, I'm running out of space. So it would be bonded to 3 H atoms. So anyways, both carbon atoms are going to be tetrahedral and the angles are going to be 109.5. Then carbon dioxide may figure out what is the shape of carbon in carbon dioxide. So carbon has no lone pairs. 4 electrons, it's in group 4, 4 electrons, 2 shared over here, 2 shared over here, nothing left. So that means they're just 2 bond pairs. If you have 2 bond pairs, the shape of the molecule is going to be like the first one, 180 degrees. It's just going to be linear. So the angles are going to be 180 degrees. Now, what about water over here? Now, when it comes to water, oxygen is in group 6. So if it's in group 6, that means it's got 6 valence electrons, which means that one is bonding here, one is bonding here. So there are 4 electrons left, or 2 lone pairs. So this oxygen atom over here has 2 lone pairs and 2 bonded pairs. So the shape would be like this: 2 lone pairs and 2 bonded pairs. So the shape of the molecule would be like this. It's going to be bent or V-shaped. Like oxygen was supposed to be tetrahedral. It should have been like this, except there is an H bonded, and on 2 sides, they're just lone pairs. So they're not going to be counted as shifts because there's nothing attached on those 2 sides. The angle would have been 109.5, but because of the 2 lone pairs, the angle has shrinked all the way down to 104.5. So the answer would be 180. I mean, the products are going to be 180 degrees and the other one would be 104.5 degrees. So it's going to be C is going to be the answer. Ye clear hai saro ko? Yes or no? Is this clear?
Yes, sir.
Okay. Achha, next one, shapes. Now this one, should we do this one or do this one at the end? Just a second. Let's do the easy ones first. Okay. We'll come back to this one right at the end. Let's say this one. So it's saying, in which structure are the 3 atoms bonded straight together in a straight line? Straight line. So that means an angle of 180 degrees. So the first one is polyethene. Now polyethene is this thing. It's CH2 and CH2. And it just keeps on repeating. यानी इसके बाद भी CH2 ही आएगा. So it just keeps on repeating on both sides. Okay, that is why you put brackets and write N. Carbon is making 4 bonds. So that means the actual shape of the molecule is going to be tetrahedral when it's making 4 bonds. The central atom, that would be tetrahedral, and the angles would be 109.5. There are no straight lines. Everything would be at an angle. It's not going to be straight. So the first one is definitely wrong. It's tetrahedral. This other one is also tetrahedral. All of them are tetrahedral. So what about propane? Propane is C3H8. So again, it's an alkane. So all of them would be single bonds. Carbon would be making 4 bonds with 4 hydrogen atoms. And again, if you look at any of the central atoms, this one or this one or this one, they're all tetrahedral. This carbon is making 4 bonds, so the actual shape of the molecule would be something like this. That it would be one carbon atom attached to the other carbon atom, which would also be tetrahedral. And then it would be attached to a third carbon atom. So all of them are going to be tetrahedral, 109.5 degree angles. So what about SiCl4? That is by default, I mean, it's just 4 bonds. Silicon is in group 4, so there are no lone pairs. क्योंकि 4 electrons थे चारों use हो गए. ठीक है, they've all bonded to chlorine, so there's nothing left. So that is going to be tetrahedral anyways. अच्छा, SF6, that's 6 bonds. Something that makes 6 bonds. So 6 bonds का ये वाला होगा आखिरी. The last one. The last one is, where's the last one? Where did it go? Let me just put a line over here so we can. So the last one. SF6 was if you have 6 bonds, one top, one bottom, one right, left, front, and back. So that is how SF6 would look like. Okay, top, bottom, there's going to be an F on the right side, one on the left side, one in front of it, one behind it. So that's 6 bonds, octahedral shape. Now in this case, 3 atoms are bonded in a straight line. So, I mean, one is on the right side, one is on the left side. So that's a straight line. That's a 180 degree angle. So option D is going to be correct. Okay, that's so option D is correct. That's fine. There's nothing wrong with that. You will in which hydride is the bond angle the smallest? So let's try and do that. Starting with, let's start with NH3. N. Remember N, when it makes 3 bonds, out of the 5 electrons, group 5, it's in group 5. Remember N is in group 5. So out of the 5 electrons, 3 of them are bonding. So that's one lone pair left. So if it's going to be pyramidal, there would be 3 bonds, and there's going to be a lone pair that would be sitting at the top. Okay, just like which one? This one. One lone pair and 3 bonds. And the angle would be 107 degrees. That would be the angle that you'll have. So the next one is C2H6. That is 2 carbons and 6 hydrogens. So each carbon atom is making 4 bonds. So that is going to be tetrahedral. And if it's tetrahedral, the angle would be 109.5 degrees. It's going to look like this. It's going to look like this one around the carbon atom. So this one would be 109.5. What about CH4? CH4 is by default, it is just 4 bonds, tetrahedral. So that's already 109.5. And then you have got BH3. BH3 would be fan shaped because it's just 3 bond pairs. How did I figure out that it doesn't have any lone pairs? Because boron is in group 3. So that means it's got 3 valence electrons. So one of them got shared, one shade over here, one shade over here. There's nothing left. So there are no lone pairs. It's just 3 bonds, So that's fan shaped. And when it's fan shaped, the angle is going to be 120 degrees. So the smallest angle is going to be for this one. It's going to be for NH3. You clear, Sarako? Is this clear? So most of the questions are going to be kind of straightforward. Do this one quickly. This is 4 bonds, tetrahedral. So it's going to be, this one is going to be 109.5. Remember, keep this in mind that when they draw this structure, the structure represents the connectivity of the atom. It doesn't show you the actual shape of the molecule. The actual shape is going to be tetrahedral. So what about this carbon atom? 3 pairs of bonds, that's fan shaped. So the angle would be, in this case, 120 degrees. Okay, remember this is not the actual shape. So when you have NH3, sorry, not NH3, but N with 3 bonds, N is in group 5. So that means there's one lone pair as well. So that means N is going to look like this in reality. The 3 bonds would be pushed downwards like a pyramid. And there would be a lone pair that would be sitting on top. So it's going to be trigonal pyramidal. And the angle would be 107 degrees. So smallest to the largest, it's going to be X, Y, and then Z. Okay, that's how you're going to solve this one. Again, this is about the shape. He's saying which shape is drawn correctly. So you have to figure that out. First thing, around the carbon atom, the angle would be, and he's talking about the angle between the bonds formed by the N atom. As a first thing, the carbon would be linear because it doesn't have any lone pairs, one bond over here, one over here. So all 3 around the carbon atom, all of the shapes are correct. So carbon is not that much of an issue. Around the N, what would be the shape around the N? N is in group 5, so it's got one lone pair as well. So that means N has a lone pair. I mean, it's making 3 bonds out of the 5 electrons. So 2 are left. So you got 1 lone pair, 2 bond pairs. So the shape would be exactly, I mean, it would be bent. It would be like a fan with one side missing because there's nothing attached on this side. Okay, so it's going to be like this. I mean, it's making 2 bonds, a double bond and a single bond, but on the third side, there's a lone pair. So it's like a fan with the top missing. So and in a fan, the angle is 120 degrees. So the answer is going to be, it's going to be C. So, ये वाला भी clear है? कोई question नहीं? Is this clear? Hani, is this clear, Eid? Mahad?
So could you please explain the end?
I mean, this one, the end part, is the C part clear?
I don't know, when you moved on to the N, I just got confused and everything.
I said the N part. I mean, focus on how many electrons and bonds does N have, right? N's got a double bond. I mean, it's making 2 bonds over here. A double bond. TK, remember when you're talking about shape, think of the double bond as one thing. TK, so it's got a bond over here, and it's making a bond over here. I mean, all cases, it's doing the same thing. It's making a double bond and a single bond. Hania, do you realize how to figure out the lone pair? Like N is in group 5, right? So out of the 5
electrons that don't bond.
Okay, so out of the 5 electrons, the 3 are making bonds, 2 over here, 1 over here. So there would be 2 electrons left, right? Is that clear? So
yes.
So around the N, you have a double bond, right? You've got a single bond and you've got a lone pair. So you have to figure out what the shape would look like. So the shape is 1 lone pair, 2 bond pairs. So it's going to be like this. Like so there are 3 things and all 3 would be repelling each other. The lone pair, the 2 bonds, they would all be repelling each other. So it's basically derived from a fan shape. It's going to be fan shaped around the N atom. All three are going to be repelling each other, right? The double bond would be repelling the single bond, and the lone pair would be repelling both of them. So it's going to be like a fan, except that this side is, I mean, there's no atom attached to that side, so there's nothing here. So the shape of the molecule would just be bent at an angle of 120 degrees, or approximately 120. Is this clear?
Yeah, thank you.
So moving to the more difficult question. Just want to see if there's. So let's go with this one. You're saying which pair has species with different shapes? So first one, BeCl2. So can anyone tell me, does B have lone pairs or not? It's in group 2. Would it have lone pairs or not?
I don't think so.
ठीक है नहीं क्योंकि B is in group 2, so that means it's got 2 valence electrons. One got busy over here, one got busy over here, so there's nothing left. So it's basically just 2 bonds. And if you just have 2 bonds, the angle would be 180 degrees. That's it. One would be on the right side, the other one would be on the left side. I said then the other one, it's carbon dioxide. That's obviously, we already did this. That would automatically be, I mean, that would be linear. Why? Because no lone pairs, just a pair of bonds over here, pair of bonds over here. That's it. So what about CH4 and NH4 plus 1? Now CH4 is 4 bonds, so that's tetrahedral. NH4 also has 4 bonds. Although you haven't studied NH4 yet with me, but I'll just tell you that it's got no lone pairs TK at the moment. So I'll give you that information. So N at the moment has it's going to have exactly the same shape. It's going to be tetrahedral. So what about NH3 and BF3? NH3, we've already done that. N makes 3 bonds with H's. And it's in group 5, so it's got a lone pair on top. So it's pyramidal. BF3, on the other hand, boron is in group 3. So it absolutely has no electrons left to do anything else. So it's just going to be planar. It's going to be fan shaped. It's going to be 120 degrees. This would be 100. I mean, so this one would be trigonal pyramidal. It's like a fan with the wings bent downwards and the lone pair sitting on top. This is like an actual fan, so it's trigonal planar. So the answer would be C because they've got different shapes. Sulfur chloride and water would have the same shape because sulfur with Cl. Sulfur is in group 6, so there would be, out of the 6, there would be 4 electrons that would be left. Oxygen in water also has the same issue, that it's making 2 bonds, and out of the 6 electrons, 4 of them would be left. So around the oxygen atom, it's going to be 2 lone pairs and 2 bonded pairs. So the shape hogi, that would be like this. 2 lone pairs, 2 bonded pairs. It's going to be bent, and the angle would be 104.5. So let's move to the difficult question which we had. I think somewhere over here. Now, in this case, the question was that, in which molecules do all the carbon atoms lie in the same plane? So in which one do all carbon atoms lie in the same plane? And the question is not about all the atoms, it's just about the carbon atoms. So the first thing is, I'll give you an idea about shapes, which is if a molecule is linear, I mean, same plane basically means that if you have a flat table and you put the molecule down, the molecule would lie completely flat on the table. So that means it's lying in the same plane. So if I put a linear shaped molecule onto a table, it's going to lie right next to the table. It's going to be lying flat, completely flat. So this thing is planar. I mean, you can put it in a plane. This fan thing is also trigonal planar. That way is also planar. I mean, this one is also planar. Remember, all bent or V-shaped molecules are planar. I mean, you can put it completely flat on a tabletop and it would lie completely flat. This one will not. I mean, this is a three-dimensional shape. If you can imagine a tetrahedral shape. So that shape, anyways, so this one is a good idea. So look at the tetrahedral shape. It's not going to, if you put it on a table, there's one bond that's coming out of it to the top. I mean, all the other atoms are not lying flat on the table. So the tetrahedral shape is not, it's not going to be planar. The same pretty much, I mean, these are good shapes. This is like the bent shape. You can put a bent molecule flat on a table. I mean, this is a bent, but it can lie flat. So it is a planar shape. See, all of them are given. So look at all of these. The linear can lie flat on a table. The bent-shaped molecule can lie flat on a table. The trigonal planar shape can lie completely flat on the table. This one, I think, is the trigonal bipyramidal. It's like a fan. So there's a fan in the middle, and there's a bond coming on top of it, and at the bottom, it can't be planar. Tetrahedral cannot be planar. This is the octahedral shape. One bond on the left, one on the right, one on the top, one behind it, one in front of it, one on the left side, one on the right side. So this cannot be planar. So this kind of gives us a good image. But let me just copy this image. It's a good image. वो notes में आ जाएगा. So we can just copy this. So this one. Now, the point I'm trying to make here is, remember, he did not talk about all the atoms. In this particular question, if you go back to this question, he's talking about just the carbon atoms. So be very careful about he's only talking about the carbon atoms, right? So if I pick any other non-planar shape, like even the octahedral shape, okay, for example, even this shape over here, even if I pick a trigonal planar shape, if you're talking about all the atoms, then it's obviously not planar if I talk about all the atoms. But let's say if I talk about this atom and this atom and this atom only, then these three are lying in the same plane. I mean, they can be completely planar. Even this one can be planar. Like if these two were not there, then these three would be completely planar. I mean, this atom, and this atom are lying in exactly the same plane. Similarly, in a tetrahedral shape, I mean, all four are definitely not lying in the same plane. But if I talk about this atom and this atom and this atom, and I cut the molecule in the middle, these three are lying in the same plane. This is coming out of the plane on the right side. This is coming out of the plane on the left side. So the point is that even if the shape is not planar, a few of the atoms could lie in the same plane. I mean, even in the octahedral shape, these three are lying in exactly the same plane. So the point we are trying to make over here is that in this particular question, he's not talking about all the atoms. He's just talking about the carbon atoms. So even if the shape of the molecule is like this, and the carbon atom is on top over here, there's a carbon atom and there's another carbon atom over here. You can think of the carbon atom lying in the same plane. If I cut the plane in the middle over here, they would lie in the same plane. So I'll just stress this point. If I have an octahedral shape, we had this one. So even if you look at this octahedral shape, like ignore these two bonds. The point I'm trying to make is these carbon atoms are lying in the same plane. I mean, forget the carbon atoms. These three atoms are lying in the same plane. This one is coming towards you. The other one is going behind you. So they're probably not lying in the same plane, but the three of them are lying in the same plane. Okay, let me just go back to that. We're running out of time, so I'll just ask you a simple question. These three are obviously planar. They're lying completely flat. Okay? But does everyone get the point that if you're not talking about all the atoms, I mean, if you're just talking about this atom, and this atom, these three are lying in the exact same plane. Do you get the point? I mean, you get this point. Is this clear? Hani, is this clear? Acha.
Yes, sir.
So you have to be careful. Is the question talking about all the atoms or just a few of the atoms, right? Same as with this one. Like if he's just talking about these three atoms, then these three atoms are planar. I mean, the other ones are not. I mean, even if you bring this in, these three would be planar. This one is coming towards you. This one is going into the board, so they can't be. As a planar means lying flat. I mean, can they lie in the same plane? Like if you have a page, I mean, if these two bonds were not there, if they were lone pairs on that side, right, then this would be a completely planar molecule. Planar means you have a tabletop, you put a molecule on top of it, and it lies completely flat, or the atoms lie completely flat on it. Jisa ye nahi padhe hue. Afin, do you get my point? So, but the thing with this question is this question was slightly trickier because he wasn't talking about the whole shape, he was talking about some of the atoms. So even if the shape is three-dimensional, it's not planar. I mean, it obviously isn't planar. Some of the atoms can still lie in the same plane. I mean, these three can lie in the same plane. These three can also lie in the same plane. I mean, these two are obviously, one is coming out and the other one is going in, so they can't lie in the same plane. So we'll discuss this in a bit more detail, because remember this question was difficult. And since it's got to do with shapes, so we'll talk about this in the next class then, okay? And we'll just do the last question over here. Baki, the otherwise, most of the questions are fairly straightforward and simple, okay? Chadiye, let's continue tomorrow then. Okay, everyone.
Allah Hafiz.
Take care, Allah Hafiz.